All right. Well, thank you everyone for joining us today. Today you're going to hear, I'm Nathan Wilkerson. I'm the VP of Engineering with Securitode. Today we're going to hear from Pocius, who's a data engineer here at Securitode. He's going to walk through some ETL process and examples. And Vitor Freitas, who is from Amazon as a senior partner SA, who's going to walk us through a couple of their services to use with ETL. So today we're going to go over Securitode very briefly here. Then we're going to dive straight into ETL for machine learning, an overview of AWS Glue, a case study that we have worked on here, and then some time. Stacy's unfortunately out, so we'll have Joaquin here for answering some questions on POC, and then questions at the very end for everyone. So Securitode is a certified Amazon advanced consulting partner with competencies in machine learning and digital customer experience. We've built some machine learning and data pipelines and ETL processes for companies like Daimler, Siemens Gamesa, and Securitode, which you'll hear more about in a little bit. If you like this webinar, please look forward for other ones coming out. We'll have one on August 7th on training models with SageMaker, and on August 28th with AWS model development or deployment. Apologies. Without further ado, I'm going to hand it over to Ray, who's going to talk about ETL for machine learning on Amazon.
Great. Thank you, Nathan. Today's webinar will be about ETL for machine learning on AWS. Companies often face a number of challenges when it comes to preparing data for their needs. Companies encounter many different problems when it comes to preparing data for analytics or machine learning. You may have data coming from several different sources, maybe different S3 buckets or RDS instances, and you want to consolidate them in a single space in a standardized way. Some people have data that is unclean and unstructured. They need a way to prepare it for their analytics or machine learning needs. The data may have unnecessary duplicates in it or missing column values, or the data may need to be structured in a completely different way before being used. People also often have a target database with some needs. Maybe you're trying to prepare data for a particular algorithm that you want to train using SageMaker training jobs, and all your training data needs to be standardized in a particular way. The solution to these problems is ETL. What is ETL? The E stands for extract, which represents taking data from multiple data sources. The T stands for transform and represents how we can change the data for our target database's needs. This can include cleaning up the data, deduplicating it, omitting data that has missing attributes, maybe normalizing it, filtering it, joining it, combining different fields. There are many different ways you could transform your data. The L stands for load. Once we have the data transformed, we're going to want to load it into a target data source. ETL can help improve data quality by making sure it's consistent. It can speed up processes, and it can also save costs. Manual data integration and reporting is expensive and time-consuming, so building automated ETL can greatly reduce the time to prepare data for machine learning and analytics. Now that we've identified some ETL needs, there are some challenges with implementation. Building ETL processes from scratch can be a very costly process. Development teams can also run into issues with scalability, implementing the right security measures, designing their ETL such that it's reliable, and implementing it for high performance. AWS's ETL service Glue helps address all of these challenges. Vitor will now give us an in-depth dive into AWS Glue.
Good, thanks, Ray. Just give me a second here. All right, I hope you guys can see my screen. Right,
Yes.
thanks again, Ray, and thanks Securitode team for having me here today. Hello, everyone. Thank you all for also being here today. Yeah, let me start talking about AWS Glue. into the next slide right here. Yeah, so as you can see in this statement right here, AWS Glue is a serverless data integration service that can be used to support ETL, not only in ML, but in many other types of pipelines. But today we are talking especially around the ML. So yes, it is a great service because it provides a number of key capabilities that make it well suited for this particular purpose of ML applications. So let's have a look on a couple of interesting features of Glue. So first of all, Glue is scalable, and that means that Glue can scale to handle terabytes or even petabytes of data, which is often necessary for huge ML projects, right? Also, Glue includes a built-in library of data transformations, this data transformation functions that can be used to clean, transform, and enrich the data. And this obviously makes everything easier to prepare in terms of to prepare those ML algorithms, right? Because the functions, you don't have to build them, they're already there. And Glue also provides a centralized and unified view of all of your data. And this definitely makes a lot of sense and helps a lot in order to track the lineage of your data and to ensure that your data is compliant with all the regulations, for example. And then in terms of finding your data, AWS Glue can actually connect to a variety of data sources, including AWS data sources and also on-premises sources too. And it can also ingest the data from a variety of streaming sources, for example, such as Kinesis data streams or Amazon MSK, the managed stream for Kafka, just a couple of examples. And then to improve the user productivity, AWS Glue basically provides a variety of features, such as graphical user interface, command line interface, APIs that you can leverage within your programs or applications, all of that to simplify the usability on your ML pipeline. And further on the features, in addition to these capabilities, AWS Glue also offers a number of other features that are very useful for, especially for ML projects such as data quality checks. So within Glue, you can automatically detect and fix data quality issues. And you know that this can really help you to ensure that your data is accurate and reliable. And that's important for ML, right? They have to be accurate. And then we also have this data lineage that can be achieved through AWS Glue Data Brew, for example, that basically allows you to track the lineage of your data, which can then help you to understand where your data came from and how it has been transformed and processed along this pipeline. And this can help you in terms of debugging the ML models and understanding how those, how to make this precision on the MLs, those predictions, and where the data is coming from, and etc. And then monitoring and alerts, Glue can obviously offer you tons of monitoring data for your data integration pipelines, and it can also alert you if something goes wrong. So this is in order to help you to prevent, for example, data loss, or to ensure that your pipelines are running, just to ensure that they are running smooth and there's no issues, etc. And authoring capabilities, it also offers a bunch of different authoring capabilities to different personas. And let me expand a little bit further on this aspect here. So in Glue, you have the Glue Studio, which is a visual authoring tool that basically you can use, anyone can use, like business analysts or data scientists, just in order to create and manage data pipelines, to create Glue jobs with just the simplicity of drag and drop interface. That makes it easy to create pipelines and to include libraries of pre-built transformations and everything that you might have. You can just bring it and just plug it into the Glue Studio and then use it to clean, transform, and enrich data without writing too much code. And there's also the notebooks and the Glue notebooks. For example, it runs on top of Jupyter Notebooks environment. So if you're familiar with it, you know how data scientists really loves to use notebooks and to run their Python codes and to interactively work with the data at the same time they're building the jobs. So that's really a powerful environment for data exploration and analysis and all that, and to also integrate with your overall pipeline. And then there's the Data Brew, which I mentioned. Basically, it's a visual data preparation tool that can be used by data analysts to clean and prepare the data. And it is very simple. It looks like kind of a fancy Excel spreadsheet where you have all the functions, everything in there, just to select and start preparing and enriching your data. And of course, all of this can be leveraged in order to build and manage complex ETL pipelines meant for machine learning applications. So, quick example of how AWS Glue can be used to support an ETL pipeline for ML, for example. Extracting data from variety data sources, you can do that with Glue because it structures from everything within AWS pretty much, and a couple of things outside AWS also. So it makes it easy to collect this data and bring it to your ML projects. Clean and transforming, as I said, there's a bunch of built-in functions, so I'm not repeat that, but yeah, there's a bunch of things that you can already use out of the box without having to code. Enriching the data, you can enrich everything, for example, adding timestamps or geolocation to support, for example, to contextualize your data. That's very important when you're building ML models. And then also loading. Once you're done with that, you have to load somewhere, and Glue can help you with loading this into a data warehouse or like Redshift, for example, and or somewhere else, an S3, etc. So yeah, Glue is a powerful tool that can be very useful in supporting your ML pipelines because it's very cost-effective, it's a scalable solution, and can be used by pretty much everyone with 0 to no skills on programming because it offers visual tools also. And just to continue, one interesting AWS service that also can be used together with Glue to create a much more complex ETL pipeline for ML is actually the step function service. So what is step functions? Basically, the step functions is a serverless workflow execution service that can be used to orchestrate the execution of multiple Glue jobs. So by combining Glue and step functions, you can pretty much create workflows that can automatically process data from a variety of sources, clean this data and transform this data, and then load it into data warehouses or other destinations. And this can basically helps you to automate your entire ML pipeline and to improve the efficiency of your ML module development as well. So here are some benefits of using Glue and step function together to create ETL pipelines for ML. Easy of use, obviously. Both Glue and step functions, they are serverless services, which means you don't have to worry about managing any infrastructure. You can simply start focusing on developing your ML pipelines. And then there's the scalability, which I already spoke for Glue, but step functions also can scale to handle the terabytes or petabytes of data. This means that your ML pipeline won't starve from resources as your data starts to grow. And then there's the cost effectiveness factor, which is very important. Glue and step functions, they pretty much pay as you go services. So you only pay for the resources that you use while they are in use. So again, this can help you save money on ML pipeline development costs as well. And lastly, we cannot proceed without talking about security. Glue and step functions are very secure services that are compliant with a variety of regulations. This means you can be confident that your data is safe and secure. And just to talk a little bit more on step functions, just the benefits of step functions all along, AWS Step Functions supports visual workflows that can be created using the AWS Step Functions console, which makes it easy to create and manage the state machines without writing a single line of code. You do everything graphically. But once you build your state machine, the Step Function service will then manage the logic of your application for you. It will then implement the basic primitives such as branching, parallel executions, the timeouts, and it will also manage the state, checkpoints, restarts, all of that for you, just to make sure that your application executes in the order as they are expected to execute. And because it also offers built-ins for try catch and retries and rollback capabilities, step functions can also deal with errors and exceptions automatically when they happen in your workflow. And just to continue here, apart from the visual stuff of AWS Step Functions, it also supports a variety of authoring languages, which includes JSONs, its own SDK. It supports for Lambda, which gives you flexibility in basically how you create and manage your state machines. So if you are looking for a powerful and versatile way to create complex ETL pipelines for ML, then yes, Glue and Step Functions are a great option, and that's exactly what Securitode is doing, they're using and leveraging. Just to finish, here's a quick example of how both of these services can be used together. to create an ETL pipeline for ML. You can use Glue, for example, to extract the data from a variety of sources, as I mentioned. And then you can use Glue again to clean, transform the data using that variety of built-in functions that I mentioned, or your own custom functions that you can bring to Glue. And you can use the step functions to orchestrate this entire thing, the executions of these multiple Glue jobs you might have. Further down, you can use step functions to send alerts if there are any errors in the data processing in the pipeline, or just to say success on everything that you need to be alerted on upon success. And then you can just use step functions once again to load the data into machine learning frameworks such as Amazon SageMaker to start working on your MLs. So that's pretty much how you can leverage these two tools. And again, this is just an example of how Glue and step functions can be used together, but there are many other ways that you can use these two services together to create much more complex things in terms of data processing workflows. And I guess that's exactly what Ray will talk to you about in the upcoming slides. So thanks, everyone. Back to you, Ray.
Thank you, Vitor. See, I might need control of the slides. There we go. Great. Next, I'll go over a brief case study of an ETL solution for one of our clients, Securitode. So Securitode came to us with ETL and ML needs. We then collaborated with them to best understand their data needs and how ETL will address the issues they're facing for their ML algorithm. They needed an ETL strategy that is scalable, secure, and reliable. So Securitode is taking CloudFront logs from several different of their clients' S3 buckets who use their platform, and then uses an algorithm to produce scores to show how much of a threat certain activity is on a client's site, and then stores those scores and insights for analytics further down the line and for security management. Data from CloudFront logs comes in as zipped files that, when unzipped, aren't exactly the cleanest to use with their algorithm. Data is not in a CSV format. It also includes a lot of extra data that is not used by the algorithm. So we had to use AWS Glue job to deduplicate it, reduce the columns to only what's necessary, and to join necessary attributes to be as input for their algorithm. The data was then stored in a target S3 bucket called preprocessed data. That data was then used to invoke their model to generate results, which were then stored in S3 and DynamoDB. After processing the data with the last ETL job, we used the AWS Glue crawler to prepare data for AWS QuickSight and another ETL job to create training data sets to improve their model over time as more data comes in from their clients. So what's next after Glue? Once you've used ETL jobs to load your data to a target S3 resource, you can easily integrate S3, Amazon FSx for Lustre, or Amazon EFS as data input channels for your SageMaker training jobs. So you can configure up to 20 different training input channels from different data sources for a single training job. And you can configure 3 different modes for these channels. The first being file mode, which has SageMaker copy the contents of those S3 buckets to your ML instance on AWS. There's also fast file, which exposes your data set on S3. It's a POSIX file system for ML instance to access. And finally, there's pipe mode, which streams a data set from those S3 buckets to your ML instance using a Unix pipe. So once you've gotten to this point, you're ready to start training ML algorithms using AWS SageMaker. And with that, I'll hand us over to Joaquin to talk about our ML proof of concept funding opportunity.
And the timing couldn't be better. So one of the exciting things about AWS and working within the AWS ecosystem is essentially unlocking the funding that AWS provides. So proof of concept funding is designed not just for ML solutions, really for any sort of concept that can be launched on AWS, but is really applicable for ML, where you might not know the future, you might not know exactly what you want to do with your workload. And really what you need to do is you need to get into the systems and actually start building things before you can really determine if what you're trying to do is going to be viable. So the program that AWS has put forward is called Proof of Concept Funding, and it's designed around looking at what is the projected annual spend for a particular workload, and then taking 10% of that annual spend and using that as a seed to help build those out, to build the proof of concept to support that workload. And I'm trying to remember if there's another slide after this or if it's the only one. Nope, just on to questions. So in short, this is something that can be unlocked by any consulting partner, qualified consulting partner like Metaltoad. If you have a concept that you would like to think about, maybe explore, generally the process is just going through doing a sort of an hour or two brainstorming session, figuring out what that proof of concept might be, putting together an AWS simple calculator, and then proposing that as something that would be available for funding. And if you have any questions about that, we would be happy to answer that. But I saw that questions are next, and I'm going to see if we have any questions from people who are attending.
Thank you, Joaquin. We have a couple of questions here. First one's come in is, what kind of problems can unclean data cause the customer? Ray, can you answer that one for us?
Yeah, I can answer that one. I think immediately a common problem that people run into is that if somebody is preparing data for a machine learning problem, if they get unclean data that has duplicates in it, that have missing column values, this can cause a problem for developers downstream, as in they'll have to clean this data up themselves when they do their experiments. Or you could have bad training data sets that are filled with duplicates, and you might have the impression that you have more data than you actually do. So that's one problem as well, but I think this applies for any kind of downstream application use cases. Like if the data isn't standardized, then we can't always rely that it's going to work in every case scenario.
Thank you, Ray. The next one here actually comes up with a couple is, why is serverless option better than the traditional one? There's a couple reasons for this. One is you're only paying for the resources you use. You're not paying for a large server sitting around doing nothing most of the time. So especially in development, you can run one or two processes at a time. While they're running, you pay for it, whether it's a little data or a lot. And then when you're ready to go live, it's just a matter of scale. You put more data in, more things will turn on and off for you. So the serverless takes care of all that orchestration for you. That said, if you do have a very consistent data flow coming in, it may be cheaper not to use serverless. It just takes some evaluation of that metric for you. And then, are there other ETL tools for AWS? Vitor, is that one you can answer?
Sorry, come again? What was the question?
Are there other ETL tools for AWS?
Oh yeah, I mean, Glue is the default ETL tool. I mean, it was purpose built for this use case, but you can also achieve ETL with EMR, for example. But again, EMR is a little bit more complex service because it comes from a Hadoop background, so big data background. So people have to understand how this Hadoop framework work exactly with EMR. Glue is a straightforward, out-of-the-box ETL tool. You don't have to manage infrastructure or anything. It's just start altering your jobs and running. So that's why it's simplified for this intention. You can also run ETL with SQL, right? So depending on how your data is, like if it's a CSV file or something like that, that Athena can read, you can use Athena to transform, do simple transformations using SQL commands, like in the form of create table statements, where you just get the data from one form, and then with select statements, you just turn that into a different format and store somewhere else. So that there are a couple of ways that you can do transformations in AWS, but Glue being the major tool purposely built for that.
Thank you, Vitor. Just a couple more, but we are out of time. If people can hang around 1 second. How do you run these at scale? If you're running this on serverless, something like Glue, it's a matter of just putting more data in. You should double check the services you're using. to verify there's no limit that you'd have to ask Amazon to raise. They do put in guardrails to make sure you don't rack up too large of a bill and to make sure they have enough capacity for everyone. But other than that, it's just serverless. You put in more data, more stuff gets processed. And then what are the factors that influence the pricing and costs of Glue, and how can users optimize the ETL workloads to minimize these costs? Is there anything we should be aware of as devs? That's a lot of questions there. Take them one at a time. Vitor, what are the pricing dimensions that are currently used on Glue?
Yeah, like I said throughout the presentation, Glue works on the pay-as-you-go model. So basically, you pay while your job is running, and the least cost structure in Glue is called DPU, and you pay per DPU, and you're gonna select how many DPU you want your job to use, and that's about 44 cents per DPU. And obviously, there's auto scaling and a couple of techniques you can do to help you find out the best DPU value for your job. But again, that's the minimal cost unit is a DPU in AWS Glue. And again, you just pay while the job is running.
Thank you. Joaquin?
Yeah, I had a question. I'm not actually able to put it into the Q&A because I'm a presenter, but I'm curious if Glue supports imputing missing values using the computed mean, which is a pretty common solution.
Not out of the box. We don't have that as a built-in function, but you can definitely write this up, for example, on a custom Python library, for example, and import it into your Spark job, by Spark job. And that will be considered as a function, and it's still going to leverage that.
Gotcha.
Thank you.
Thank you.
Unfortunately, we are out of time for the day. So thank you everyone for joining us at our webinar. As I mentioned, we have our next webinar coming up in August on the 7th on training models with SageMaker. So please keep an eye out for those invites, and we hope to see you then as well.
Thank you,
Thanks, everybody.
everybody.